Hello, everyone. In this video, I will be going over the actor-partner interdependence mediation model. So we will be testing the indirect effects using a cross-sectional sample of data from couples to expand on the actor-partner interdependence model. So if you have not yet watched the videos that go over and cover the actor-partner interdependence model with distinguishable and indistinguishable dyads, those might be more appropriate places to start, but you should be able to stay with us if you are familiar with those models, but I have not yet seen those videos. And so we are going to be, again, testing mediation. We're going to be using 6 variables altogether. We're going to be looking at dyadic coping, relationship quality, and depression in males and females among heterosexual couples. And so what we are going to do first is we are going to use, I'll show you mediation in 2 ways. We'll do bootstrapping first. And I'll show you the code and syntax for that. And then we will also do mediation via robust maximum likelihood, or MLR, within Mplus. All right. So for those of you who have watched the previous videos, the syntax should look fairly similar and fairly familiar. Here we have our dependent variable. So our model is going to be that depression predicts dyadic coping, which predicts relationship quality. This will be CESD. This will be dyad cup. This will be CSI. All right. If I throw an exclamation point there, then I'm telling Mplus to skip over this text. It is nonsense text and it is not involved in our analysis. And so this is a way I actually keep notes to myself. And I actually parcel out my primary model from my covariate portion of my model. All right, so here we have our dependent variable, and it's being predicted by our mediator, which is dyadic coping, and our independent variable, which is depression for both male and female partners. All right, so you can kind of think of it as kind of like a hexagon. If you are if you're a visual, then you can imagine 2 IVs that are correlated with one another, predicting 2 mediators that are correlated. And then they converge and they predict 2 dependent variables that are correlated. All right. And so this is the male line, right? And then this is the female line. And again, there's a variety of different ways to write this syntax. So Mplus is actually fairly flexible in how you write your syntax. It's really all about what you are going to do in your second and third and fourth and fifth steps. That dictates the way I write my syntax in Mplus. And I've written it in a different way in the second line, so you can get a feeling for some of the flexibility. So these are essentially equivalent statements. I technically don't need this line here. All I could do is just copy female up here, and that works perfectly fine. These are equivalent. You'll get the exact same result, exact same answer. Right? And so we have our DV being predicted by everything, by all the 4 other variables, including our mediators and IVs. And here is where we have our IVs being regressed on, which is analogous to being predicted by our independent variables, which is depression here. And we specify a covariance between each partner's reports of the variables. So we specify a covariance for relationship quality, for depression, and for dyadic coping. And that represents the non-independence, which is the motivation behind the actor-partner interdependence model in the first place. We want to account for that non-independence, because if we were just to analyze all of these couples together, we would have downwardly biased standard errors, which means our test statistics would be too large, which means we will be making type 1 errors because our p-values are going to be way lower than they should be. All right, so all of this is probably standard syntax from if you've seen the previous videos. The new syntax that you might not be familiar with if you haven't tested mediation in Mplus is the model indirect command. And this is essentially specifying every indirect effect that we want estimated within our model. And so Mplus requires you to specify each indirect effect kind of on its own. So unfortunately, you could not do something like this, where you can have multiple variables on your right-hand side of that indirect effect statement. That still, to my knowledge, does not exist within Mplus. So you have to code it, each indirect effect individually. All right, so what's beautiful about this command, that's kind of one of the hassles, is that you just have to specify your IV and your DV. All right. And Mplus is automatically going to test every individual indirect effect that is in the model. So any way that your independent variable can get to your dependent variable through regression coefficients, through on statements, is going to be estimated for you. And so we will be testing the indirect effects from male relationship quality to female depression, male relationship quality to male depression, the indirect effects from female relationship quality to female depression, and then the female relationship quality to male depression. And so this will give us quite a few indirect effects. So when we go through that output, we will see, I think approximately 12, if I remember correctly, 12 indirect effects in total. So I have bootstrapped this. And so depending on your computer, it's probably going to go pretty quickly. I only did 500. Typically, you want to do 1,000, 5,000, or 10,000. But just for the sake of demonstration, we did not. So you can ignore all of these warnings. They're just related to bootstrapping, and some of my standard output that I request, such as plot and outliers and things of that nature, are not available in bootstrapping within Mplus. You need to do that before you do your bootstrapping. So again, checking your summary of analyses. It's always good to check the number of groups, the number of observations, to be sure that Mplus has not dropped your independent variables, which it will do if you are missing data on your X variables or on your covariates. All of your exogenous variables that are going to be on your left-hand side of your path diagram. To ameliorate that, you can always add in a FIML statement where you just tell Mplus to freely estimate a mean and a variance, and you can trick it into applying full information maximum likelihood to your independent variables as well, so you don't lose those cases. So shifting over to my univariate statistics, I'm just scanning over these to be sure that I don't have a missing data code that is misplaced or miscoded. My skewness and kurtosis, taking a brief look at those to see the extent to which my variables may or may not be distributed. Again, the skewness and kurtosis kind of gives you a rough estimate of the distribution of your variables, but remember, the distribution of your variables is centered on the residuals, not your marginal distribution. So skewness and kurtosis, while informative, are not the end-all be-all when determining whether or not you have violated that assumption. So we will scroll down to model data fit. With your baseline actor-partner interdependence mediation model, you will always have a saturated model if you are estimating all of the direct effects. All right, so your model doesn't have any degrees of freedom. You haven't imposed any restrictions on your model. Everything that can be estimated, you are estimating. Okay. And so this will always be 0. RMSEA will always be 0. CFI, TLI will always be 1, and your SRMR will also be 0. Okay. So now we can move down to the model results. And so we can look at these are the unstandardized. So in model results, these are unstandardized coefficients, and then our standardized ones are down here. And so what we can look at first is that dyadic coping has a strong, perhaps positive relationship with relationship quality among men. So a 1 unit increase in dyadic coping is a 0.469 unit increase in male relationship quality, and that is significant at P is less than 0.001. We can look here at the partner effect. So again, this is an actor effect. I can type that in right here. And F, that is going to be a partner effect. And that is non-significant. All right, so that's our p-value in that 4th column now that it's shifted. So after accounting for the influence of male dyadic coping as well as male and female depression, the effects of female reports of dyadic coping are not significant, are not a significant predictor of variation in male relationship quality. All right. And so we have the female outcomes here. And so we have here that women who report a 1 unit increase in dyadic coping experience a 0.224 unit increase in relationship satisfaction or relationship quality. And we have that women who report higher levels of depression also experience lower levels of relationship quality, such that a 1 unit increase on depressive symptoms measured by the CESD is associated with a 1.67 unit decrease in relationship quality. And so this is our dependent variable, and these are our mediators right here, and then our independent variables over here. And so now we are going to shift over to our unstandardized effects on our independent variable predicting our mediator. And so what we have found is that we have 2 significant actor effects. So for male dyadic coping, male depression is a significant predictor with our p-values 0.03. And for females, it's 0.011, and they are both negative. So the more people are depressed, more couples are depressed, the more individuals are depressed, the lower the level of coping with stressors together. And down here, we have our covariances between our male and female reports on each of the variables. We have our means for depression, as well as our intercepts for our endogenous variables, as well as our variances and our residual variances. So we will scroll down. I will not spend too much time belaboring what we have just talked about in terms of the actor-partner mediation model results, but we are going to show that we're just going to place these effects on a standardized metric. So now we are talking about standard deviation units, which are a little bit more interpretable for many of the measures that we will use in the behavioral sciences and psychology and family science and human development and public health and things of that nature. All right. And so we'll scroll down and we'll see how much variance is accounted for. And we can see that we account for a fairly substantial amount of variance in male relationship quality, but we still account for quite a bit of variance in female relationship quality, but it is substantially less than male relationship quality. Right. So those are our kind of direct effects and our variance explained. So now we're going to go down to our indirect effects. And so here You will have your indirect effects, which is based on the delta method in Mplus. And we can look at each individual effect. And so the p-values are really helpful to tell us whether or not the multiplicative result of that alpha path and that beta path, our IV from our mediator and our mediator to our DV, is statistically different than 0. However, I tend to skip over these results because I want to scroll down. I want to look at the confidence intervals around that. And what the confidence intervals give me, they're first going to show you the confidence intervals around each of the individual paths within the model. But what confidence intervals give me is I can see kind of the spread of how wide the 95% confidence interval is. And that'll give me an indication of kind of how stable my model is, how precise my model is, and how well my model is explaining the variance. Because we want really, really narrow confidence intervals. That means we can be really, really confident that our value or our parameter estimate is precise, and there's not a whole lot of variation in the explained effects, right? And so that's something we really want to be mindful of. And so here we can see that our confidence interval is actually pretty wide. It's not really, really tight, but given that it's a small sample, that's not surprising. Again, this is only a sample of 125 couples, so it's an N of 250. So again, I'm not all that surprised. And so again, we can scroll down and look through all of the effects, but we're going to scroll down and look at the standardized effects. So looking at the specific indirect effect from female depression to dyadic coping for males. So that's going to be a partner effect. So female depression to dyadic coping for males, the partner effect. To male relationship quality, which is another partner effect. So we're multiplying two partner effects together, which tend to be smaller on average, and it is not significantly different from 0. And this has a pretty wide confidence interval. And that tells us that I'm not at all confident that there is that this indirect effect is significant. Right. So this the specific indirect effect 2 is for relationship quality for males, goes through CESD for females and dyadic coping for females. So that's going to be an actor effect here from female depression to female dyadic coping, and then a partner effect to relationship quality with males. All right. And so those are the two pathways by which female depression impacts male relationship quality, and neither one were significant. All right, so we cannot say that female depression is indirectly related to male relationship quality. So scrolling down to male depression impacting male relationship quality, we have our first kind of significant effect. We have, this is our confidence interval. On the outside, it's your 99%, and the second one in is going to be your 95% confidence interval. And as you can see, 0 is not in between them, which means that we can say that the effect is significantly different than 0. So essentially what that means is that we can say with 95% confidence, this is not necessarily a probability statement, but we can say with 95% confidence that assuming that the null hypothesis was true, it would be highly unlikely that we would have found this effect this large or larger, right? So given that null hypothesis is true, is a really critical piece of the interpretation something that scholars often struggle with. And so we can say that male depression is indirectly related to male relationship quality through male dyadic coping. Okay. And the second indirect effect, again, this is an actor-only effect. Okay. The second indirect effect from male depression to female dyadic coping to male relationship quality. So that's going to be a partner effect, where we're multiplying the partner effect from the IV to the mediator and the mediator to the DV together. And that is not significantly different than zero. We do not have any evidence to say that this is significant. And so now we are shifting to CESD for females to being indirectly related to the CSI for females as well. And we can see that partner effect, that same one that we saw with males that was non-significant. It is likewise non-significant here because our confidence interval includes 0. All right. So these will not give you any different answers than the indirect effects I skipped over up here. Because either you are dividing by your standard error or you are multiplying, adding or subtracting by 2 times your standard error to get your confidence intervals. So again, they're not going to, they're different anyway. I just think the confidence interval gives us a little bit more information than a p-value. And so we actually see the actor-only indirect effect is not significant, kind of just by a hair. So despite up here, when we scroll all the way back up to our findings, we found that female dyadic coping is associated with female depression, and we found that female relationship quality is associated with female dyadic coping. So both of our alpha and beta pathways, our IV to our mediator and our mediator to our dependent variable, are statistically significant, but when we multiply them together, it is not statistically different than 0, which can happen in mediational and in mediational analyses and the estimation of indirect effects. So that is something to be aware of, that you cannot simply assume that just because you have 2 significant direct effects, that the multiplicative coefficient between the 2 is also significantly different from 0. And some of that will have to do with your precision around your standard errors. As you can see here, the standard errors are a little bit higher for this actor effect, and that might be a potential, limitation in your study of why you can detect this. Perhaps the study is underpowered, and I would say it probably is underpowered with only 125. But you'd have to think through why that might be, why you would get a non-significant indirect effect despite 2 significant indirect or 2 significant direct effects. So we'll scroll back down to our output. And our final set of indirect effects are here as well. And again, this is where we are going to do, this is an actor partner from the males, depression to dyadic coping, and then a partner effect from male dyadic coping to female relationship quality. That's not significantly different from 0 either. And neither is the effect from a male depression to female dyadic coping to female relationship quality. So really, we only have significant effects for the actor-only indirect effects for males, okay? And so that is how you test indirect effects using bootstrapping procedures. And now I will quickly walk you through using robust maximum likelihood, which tends to be my preferred way of testing indirect effects, because I found that the normality of our residuals that assumption is very rarely met. And so I like to adjust for that, and I sacrifice the bootstrapping creation of a sampling distribution of those indirect effects in order to do that. And so let's see if we can actually take a look at our residuals to see whether or not they are normal. And we actually want to use histograms and go to our residuals. And we can actually check out residuals for the mediators as well. And so here's dyadic coping for males. As you can see, there's a general kind of shape, so it doesn't look horrible, but also you have some gaps here. Over here there's a little bit more of a pile up, and so it doesn't look, again, phenomenal, but it doesn't look horrible either. And you can pull up the descriptive statistics to look at your min and your max. You can look at your mean and standard deviations and things of that nature if you want more precise estimates of your residual distributions. And so if you click on this little chart button right here, your next variable, it'll take you to female. And as you can see, that's a little bit worse. Where for males, there was so it shifted a little bit. We'd want this one to be closer over here because we want that mean in a normal distribution. The mean, the median, and the mode are all the same value, and we want that top of the tent to be over 0. But so you can see it's slightly moved to the left, and it's over around negative 1.5. And with women, it's a fair bit worse, where it's actually the mode is over negative 4.78. And so it's getting further and further away from 0. And so we can see that the residuals for couple satisfaction index for males are also not great. We can kind of see a general curve here, but you got some violations over here, and you have nothing really in here. So again, these can provide some problems. And then obviously we have some really skewed and kurtotic residuals for the relationship quality for women. And as you can see, the mean is nowhere near 0. And so we can, say with a lot of confidence here that this is just this isn't a good representation. These residuals aren't normal, which can insert bias into our standard errors, our chi-square, and other aspects of our models. And so this is why I tend to prefer to use robust maximum likelihood. So I'll say no here. And I will add MLR. I could technically do MLM here. MLM is robust maximum likelihood, but only if you have complete data. I do happen to have complete data in this example demo file, but in reality, you will not have complete data, so you can use MLR. And that's the only piece of syntax that you need to change. Everything else will be exactly the same. And I will show you what happens. So let's say we want to try to bootstrap. Keep that command in there with robust maximum likelihood, and we will see what Mplus does. And as you can see, Mplus is yelling at us. So option bootstrap is not available with these other estimators, and that is why we have to kind of stick with just the delta method for the calculation of indirect effects. So we'll run this. It runs a fair bit quicker because we don't have to bootstrap. We're not running 500 of these models. The fit statistics will all be the same. All of that will be identical because this is a saturated model. You will notice that some of the standard errors are going to be actually a little bit higher than they were in the previous model. All right, so we actually, in the previous model, remember that the depression was a significant predictor of relationship quality, even after accounting for dyadic coping. And here in this model, when we correct for the non-normality of those residuals, this falls to non-significance. So generally, your parameter estimates are not going to change. And if they do, it's going to be very, very minuscule. You're going to see changes in your standard errors. And so elsewhere in the model, much of the other results are exactly the same. But we do see that there are a few changes in the model in relation to depression. All right. So down below, we have our same confidence intervals. And this is what we would report in our manuscript write-up or our conference presentation, these exact same intervals. I'm not sure if you were tracking from the previous confidence interval, but this confidence interval is actually a little bit narrower than it was in the previous example. All right, the distance between the lower and the upper bound was about 0.20, if I recall correctly. In here, it's about 0.1, was it 1.7, somewhere in there. And so you can see we're actually making that our precision of our estimates smaller and smaller and smaller, or greater and greater and greater because of smaller and smaller confidence intervals. Right. So I'm not going to go through and reinterpret these values because they are interpreted in the exact same way. But we are unable to talk about creating a sampling distribution of the indirect effects for like we did in the bootstrapping method. Here we are saying we are using the delta method with robust standard errors to address non-normality. And the reason I like MLR a little bit better is because research by Montoya at UCLA has shown that bias-corrected bootstrap confidence intervals are subject to type 1 error. And my conjecture is that part of that is due to not correcting for non-normality, because very rarely are those assumptions ever met, at least in the work I do in the context of trauma, family relationships, and mental health. Those residuals are all over the place, and therefore we need to do something about that because it can affect, and we've seen it affect our results. So essentially, that is the testing the actor-partner interdependence mediation model using two different methods of mediation, bootstrapping as well as robust maximum likelihood. Hopefully this video was helpful to you, both in understanding the dyadic mediation as well as some of the potential implications for estimators. Thank you very much, and look forward to seeing you in future videos.